action. Copy this example down. These are just the sort of working solutions I'll be doing on the side so that I can sketch. So I'm not even sketching yet, I'm just doing the solving. So I want you to copy this equation down. I've got 2 times sine of x plus pi and 3 plus 1, and I've kept the domain pretty simple as well. It's between 0 and 2 pi. You want to make that look even more tedious or take a longer time to do, change that domain. Make it like negative pi to pi, and suddenly it becomes, oh, it's still okay, and then you put the 2 here. Voila, that's 6G for you. Okay, so 6G, they'll do the same things, but they'll change that. And it just takes a long time to do. Not that you can't do it. So if you can do this question, you can do 6G. It just takes longer to do. Okay? So, first things first, I will want to find my quarter period. That's one of the easiest ways to do it. So find the period first. Look at the period. Now, right now in front of x, I don't have a value. I only have 1. I don't have a 2 in front of the brackets either. So the period is still 2 pi. 2 pi on 1 is my period. So period's still 2 pi. Okay? Now, if my period is still 2 pi, then the quarter period would have to be what? How do I find my quarter period? Divide by 4, and that's pretty much the same as what we've been doing so far. 2 pi divided by 4, we already know it's pi on 2, it's 90 degrees. Yeah, 2 pi is 360, divide that by 4, you got your 90 degrees. Yeah, so we've got pi on 2. Simple. Now we know that to go from one point to the other, it takes pi on 2 distance. That's what we know. Okay, but what we don't know is, where do we start? We need a point to start off to find out the next point, true? We know the distance is pi on 2, but we don't have a point to start off with. What I always do is I used the left-right to figure out where my first point is. Okay, I don't care about the up-down. The up-down is just sort of like an idea where the basis is, but I want to know where I move left-right. That tells you where the starting point is. Okay, but I'll do that for the next slide when we start working out on the quarter periods, on how to incorporate the quarter periods. Okay, so right now I've got quarter periods pi on 2, and what I now need is you need endpoints because they gave you 0 to 2 pi, so you need endpoints. You also need X-Intercepts. Now you see this whole chunk here, that's what you've been doing up to now. 6E was all about you solving for the X-Intercepts. Okay, so I'm going to guide you through again how to find the X-Intercepts of this equation, given that you got 0 to 2 pi. Okay, so let's try this. How do we do this? Find X-Intercepts, we would let y equal to 0. So I'm going to let y equal to 0. Now you're doing exactly what you did yesterday. Remove every part of the equation to get x by itself. Plus 1, subtract 1, times 2, divide 2 on both sides. So this is what I get. The next line is negative half equals the sine of x plus pi and 3. My goal is to get sine, remove sine, so I can get x by itself. Sine inverse both sides, I get sine inverse of negative half. And yesterday I told you to pause here, because we don't know what the answers are. We gotta formulate our answers before we write them down. So right here, sine inverse of negative half. This is where I need to work with the domain. But be careful, the domain, and I like doing it this way. You don't have to do it this way, by the way. Most students don't do it like this. They normally add more and subtract more. I like to use, since I know that this graph is already moving left or right, that changes the endpoints as well. And I always like to move the endpoints with it. You don't have to do this. It's how I do it. Okay, so you can copy it, you don't have to copy it. Some teachers would just get you to keep going through the unit circle as if it's 0 to 2 pi. Sometimes when you do that, the problem with that is you miss out on a solution. So what I'm trying to describe is, let's say this is your normal graph, true? When you move it left or you move it right, it doesn't just become this. Because it's a continuous graph, what happens is if the boundary was here, you may have this section, this new section that comes out, and we don't know if that section oscillates back again and hits again. That's what we don't know. So if you only calculate for one cycle, you may lose a potential X-intercept. So while you lose one, when you move to the left, you might gain one from the right, if you know what I mean. Yeah, so because the cycle goes up, down, when I move this graph to the left, what I don't know is whether this X-intercept here will move into this region, between 0 to 2 pi. So if you only work out from one cycle, you might miss out on one X-intercept. But if you change the domain so that it fits, like you take the cycle with it, then it will always have it within the domain. You'll always get it correct. Okay? But it just makes it look tedious, that's all. Okay, so do this if you want, or you don't have to. I just like to do it this way. So here we go. Since I know x was between 0 to 2 pi, but my x right now is add an extra pi on 3. So very similar to yesterday, when we had 2x, we times everything by 2. Well now, since I'm adding by pi on 3, I'm adding everything by pi on 3. So instead of starting at 0, I'll be adding 0 to pi on 3, and I'm starting here. That's my hypothetical start. Okay, just like yesterday, we did a hypothetical stretch, then now I'm doing a hypothetical move. Because at the end of it, I'm going to move it all back. I'm going to move it all back to where it should be. Okay, so here we go. I did an add pi on 3 on each one of them, because that was x plus pi on 3. I add pi on 3 to 2 pi, I add pi on 3 to 0. That gives me 7 pi on 3 and pi on 3. So, if you look at the unit circle, what you're used to is you're always starting at 0, and you went back to 2 pi, you started here. Well, you don't have to start there at the part of circle. You make one revolution like that. But what I'm saying is, why can't I start at pi on 3 and do one revolution and land back at 7 pi on 3? That's what I'm saying. By doing that, I will at least take cover of any intercepts that might have come in. So when I move it back, it will just fit nicely between 0 to 2 pi. That's what I'm doing. Okay? So, that's where it gets confusing for some students on what I do here. If you don't like that, again, like I said, you don't have to do this part, yeah? I'm just doing it so that I don't miss out on those intercepts. So here we go. I know now I'm starting at pi on 3. I'm going one full revolution until I get there. 7 pi on 3. That's my domain. Starting at this question, it says sine of the angle is equivalent to negative half. Sine is your y values. When is it negative half? It's down in this region here. So I know negative half is down here, so the only way to get those 2 points is if I'm either in these 2 regions here. Okay? Don't forget you're starting at pi on 3, you're starting there, not at 0. And you do the same thing. You're going from pi on 3, you have to go around the circle until you get back to 7 pi on 3. So I'm going to go around the circle, starting at pi on 3, I'll go all the way around. This is pi here. That's pi distance. But then I know that I have to add an extra amount of angle to get to this point. So this is what we were doing yesterday. This is where you ask yourself, sine of what angle will give you half? Sine of what will give you half? Pi on 6. So now I know that's pi on 6 there. This is pi on 6 here. So my first solution should be pi with an extra pi on 6. Whereas the other one is short of 2 pi by pi on 6. So I would write down now, I'd say, oh yeah, sine inverse of half, as I move all the way back to 7 pi on 3, I only cross this twice. That's it, I only get my solutions twice. So I finish my entire cycle, I get back to 7 pi on 3, I'm done. There's only 2 points that I had to worry about. These are my 2 points, pi plus the angle, 2 pi subtract the angle. I'm done. Okay, so now I'm just going to simplify that what we did yesterday. 6 times pi is 6, 6 plus 1, 7 pi and 6, 12, take on 1, 1 pi and 6. Yeah? Now I need to find x. Now remember, I did a hypothetical move before. I said I moved it by pi and 3, so I moved it to the right by pi and 3. I calculated any possible intercepts, and then I moved it back to 0 pi. So how do I move it back? If I added pi and 3, subtract pi and 3, and that's what I'm doing here. I'm subtracting pi and 3, so it moves all possible solutions back into the same sort of window. So I'm still back in 0 to 2 pi. And that should accommodate for any loose ends. Okay, so by doing that, minusing pi on 3. Now I notice that pi on 3 is just 2 pi on 6. So when I minus it, just subtract 2 on each end. So subtract 7 by 2, subtract 11 by 2. You're subtracting 2 pi on 3, which is the same thing as 2 pi on 6. Okay, so I'm just saying, instead of saying minus pi on 3 for each one, I can just say 2 pi on 6. That's the same thing. So subtract 2 pi. Yeah? Now I've got my x-intercepts. I got 5 pi and 6, and I got 9 pi and 6. Done. Those are the only 2 solutions that work between 0 to 2 pi. Okay? So that was the most tedious step. That's why I said if you don't know your exact values, can't do your symmetry properties, then you can throw out all the sketching graphs, because that's the hardest part. Okay? That's the most tedious part. That pretty much took up this entire page here. Okay? Then we go into the next one. Now I've got my X-Intercepts, I got my period. What do I need? Y-intercept and endpoints. So y-intercept is the easiest one. You can just put 0 in, sine of pi on 3. I already know it's root 3 on 2 times 2 makes it root 3 plus 1. So I already know the y-intercept is root 3 plus 1 just by looking at it, okay? So the only thing I need now is the endpoints. So I'll just write it over here. The y-intercept, I worked it out, was 2 times sine of pi on 3 plus 1. 2 times root 3 on 2 plus 1. The 2's cancel out. So y-intercept is root 3 plus 1. I need to find the endpoints. Endpoints are at x equals 0 and x equals to 2 pi. So you need to sub it in. Now, it's likely because it's an oscillating graph and it's the same, it's a cycle of 2 pi, then it's likely whatever you chop off the first end and the final end should be the same y values. So that's how it usually works if it's one full cycle. Okay? So if I work this out, sub 0 in, and you can see it gets root 3 plus 1 as well. Then I go to 2 pi, and you'll find that 7 pi and 3, remember, was exactly the same spot as well. So if I'm asking for the sine of it, it should still be root 3 plus 1 as well. Okay, so there we go. We've got our endpoints, we've got our y-intercept, we've got our x-intercepts, we've got the quarter period. Now we should be able to sketch. Okay, now this is where, even though you know it, just sketching it normally looks ugly, or you know how many cycles. That's why I'm showing you the quarter cycles. Okay, so here we go. Let's put this all onto a page. Quarter cycles. We set pi on 2. I like to start where they move the graph. Now if you read this, this is up by 1. What does this tell us? Left by pi and 3. Okay, so I would start off with the left by pi and 3, so negative pi and 3, but then it says up by 1, so this must be the middle. That's where I start. Because remember, a sine graph, how does a sine graph start? They always start at 0. So what I've done is I've taken the first point, that point, moved to the left by pi and 3, up by 1. So I know this must be the middle. That must be the middle. So this is my middle. Add 1, that's my middle. Then what's my maximum and my minimum? What's my maximum? Whoops. Oh, what happened there? Oh, there we go. What's my maximum and my minimum, Ian? Good, because we know the amplitude's 2. Okay, so it's going an extra up by 2. So from 1, adding an extra 2 makes it now 3. From 1, subtract 2, it makes it negative 1. Now, what you can already tell is if you're starting 0 on the middle, then you know the next point has to be maximum, then middle, then minimum, then middle, maximum. That's the cycle. The only problem you don't know is how far the quarter cycles are, which we worked it out. We said it's pi and 2. So starting from negative pi and 3, if I want to move to pi on 2, I have to add by pi and 2. That tells me the next distance. So I'm going to do it in blue over here. I want to find where the next point is. So negative pi and 3 plus pi on 2 is the same thing as saying negative 2 pi plus 3 pi all over 6. Or if you like to think about it, it's negative 2 pi on 6 plus 3 pi on 6. Okay? So what that really tells me is this point here is the same thing as negative 2 pi and 6. To move to the next point, it told me that I have to get to 3 pi and 6, which let's say it was over here. What I want you to see is what's the distance? Negative 2 to get to 3, how many pi on 6 do I need? I need?
Nothing.
5. So it'll be 5. So if you want to find the next one, it's just an extra 5. So I haven't done any calculation. I'm just converting it. I'm just saying negative pi on 3 plus pi on 2. Technically, the same denominators would be negative 2 on 6 to get to the next one, I have to do -2 plus the 3. Yeah, so -2 plus the 3 gives me that total part. So adding an extra -2 plus the 3 gives me now, this is pi on 6. Okay, so I've added 3 units. Okay, 3 units. So if I want to get to the next one, add another 3. 4 pi on 6. Want to get to the next one, add another 3. 7 pi on 6. Want to get to the next one, add another 3. 10 pi on 6. Want to get to the next one, add another 3. When do I stop though? 2 pi, which is where? 12 pi and 6. So I know 12 pi could be around here. So let's say 12 pi and 6. So I know if I follow that cycle, this tells me start, middle, top, middle, bottom, middle, top. And then before I even get to 13 pi, I'm not even reaching to the top yet. So you can see what I'm doing. I'm doing top, middle, bottom, middle. And then 12 doesn't even reach the top because at 13, that's where it was meant to be. But I haven't reached 13 yet. So 12 must be about here. Okay? So when I'm sketching it, I must know the y-intercept must be somewhere here. So it should look something like this. See what I'm doing? And we've worked out the x-intercepts already. We already know the x-intercepts were 5 pi and 6, 9 pi and 6 must be there. Okay, and we know that the y-intercept, which was √3 on 1, and then that's √3 on √3 plus 1 as well. So that must be where √3 plus 1 is. They're both on the same line. But it makes it easier to figure out. But all I did was just count quarter cycles. I didn't do much thinking. But the hardest step was here, not the quarter cycles. That's the hardest part to get. After that, the quarter cycles just gives you a sort of frame of what it should look like and where the endpoints should be. But you see, that took a while to do. Even if I would do it myself, it would take a while to do. It's a tedious process to do. It used to only be 3. And I haven't seen it, like 2006 was the last time I saw it. They got you to draw a cost graph. The last year's one was a tan graph. And that's easier because it's only got one intercept. No matter what kind of tan graph you have, the one cycle will always have one intercept. So it makes sense why they got you to do that one. But I haven't seen a sine or a cosine where you have to sketch in exam 1. It just takes too long to do. So what they now do is they just get you to do that part. That's your 2 marks here. That's where they get it from. Okay? They don't get you to do that anymore. It used to be a 3-mark question. X-intercepts, maximum, minimum, endpoint, all had to be there. All had to be there. It takes way too long to do. It was prior to 2006. That was a common question to do. Okay? So, that's what you're doing. That's exercise 6F. And if you want to challenge yourself, do 6G, where they put a 2 there. But essentially, it's the same thing. You're only changing the number of intercepts you're going to have, and then you'll be changing the domain, and you're changing the quarter cycles. That's it. But the technique is the same. So 6F and 6G. 6G is the most tedious. If you want to start a bit easier, 6F doesn't have the ups. 6F only moves left and right. Okay? So that's it, guys. And then we'll start moving into other properties like addition of graphs, addition of ordinates, if you remember that. And then we'll do some tan graphs, applications, and general solutions. That's it. So chapter 6 isn't much, but like I said, all your theory starts here. Okay? No. That's in Spesh. Methods is only sine, cos, tan. Yep. And I thought there was a question. All right. I'm gonna pause.